So, hello guys, my name is Max, and welcome to this second video where we continue to develop our Space Invader clone using JavaScript and HTML. So, where we left off last time, we just do the basic movement of the sprites of aliens and the movement of the tank sprite for the player into the game. But before we get started coding on any new features like the shooting and the blocking with the cities, I just want to make a small improvement to the code here. So last time I said the width of the application should be 502 pixels, but it should actually be 504 pixels. So if you see now, the aliens should go all the way to the edge of the canvas here, hopefully. Yeah, like that. So that's the right behavior there for you. And then to make sure that it change direction with offset, then we just subtract 30 pixels here from the width, and we should get back to the thing we had before here, where they go to 30 pixel offset and then go down and then to the left. So that's it, guys. Anyway, so let's get started coding our actual new features here. So to start off, I just want to implement the shooting. So to start off, just make sure that you have declared the bullets variable here at the top of the script file, and then just go down here to the let's go down here after the tank, perhaps, so just create a new bullets list like that. And then actually we will have a function that I will call create bullet, and that will take a x position, a y position, velocity in the y direction, and then what do you say, a width and a height, like that. And actually we'll also have a color, so each of the bullets should be drawn at different ways here. Actually we can call it bullet like that, I guess, like that. And then we say this x equals x, this y equals y, this velocity of y, or the velocity of y equals velocity in y direction, this width equals v, and this dot height equals h like that, and this color equals color like that, I guess. And then we can just have a update method on the bullet class here, update, I guess, and it will take an arguments, but it will rather bullet here, and then we just say this the y plus equals this the velocity of y, velocity in y direction, like so. Then to the screen, just make a new method, and we can call it draw bullet, and take a bullet as argument, of course. Then we can just say this the cdx of fill direct on the bullet for x, bullet for y, bullet for width, and bullet for height, like that. And then before here, just make sure we set the fill style to the bullet of color. So the color here is just a string hex code with the HTML color we want to use when we draw the bullet. And actually this may perhaps be better if we have it like that, so it's outside of the helper functions. Anyway, so after that is done, you just go down here to the update method or function, and after we have set the x position, we can just say if input is down, or is pressed rather, and the key code I'm after is 32, and that's the key code for the spacebar, like that. And yeah, and here we can just say bullets.push new bullet, like that, and that will create a new instance of the bullet class. And then for x position, that will set to the tank to x position, the y position is tank to y, and then the width, also the velocity is set to -8 pixels, and the width 2 pixels, and the height 6 pixels, and the color, let's set that to white for now, like that. And then we can just go down here to the render method, and then we just say screen.context screen.save and screen.context.restore, and inside of here just loop through all the bullets. So for I equals 0, len equals bullets, the length, I plus plus, I is less than len, I plus plus. And here we can say screen.draw bullets, bullets at I, like that. So for now, if we open up Chrome again, below the page, we get an error. So let's check all the errors. Let's just grab down there, see what it said. Is pressed. Okay, I missed a G there. Like that, I guess. Yep. And we got some. Yeah, of course. So it's working fine. But as you can see, the bullets aren't moving. So let's just fix that real quick. So just go down, go up here, I guess, and then we can say for bar I equals 0, len equals bullets, the length. I is less than len, I plus plus. Then bullets at I, the update. And up to now they should be moving also. Yeah. So now we can see the shooting is functioning here. But as you can see, they are drawing from the edge of the bullets of the tank sprite, and we want it to be drawn from the middle. So let's just set an offset before we do anything else when we create them. So let's go to the X here, and then just let's add 10 pixels. I think that's the right amount. Let's see. Yeah, so that seems to be working fine. And if you, well, fun fact, if you just change this down, you get this rapid firing going like this, and that can be quite fun when we do our testing. Anyway, but let's take it back to this pressed again. By the way, it's not very good, because the bullets never are removed from the game. They just continue moving out of the canvas and start updating and taking memory. So to fix that, we will check if the bullet's position is out of the canvas borders. And so let's do that. So we can say, well, B actually equals bullets at I, and we can call b.update instead. So b.update, and then we can go down here, and here we can say if b.y is actually we'll add the bottom here, so b.y plus b.height. If that is smaller than 0, or the y position is bigger than the screen height, or the height of the canvas, then we want to remove that one. So we can say continue here, just so we continue with the for loop, and then we can say bullets splice, and that means remove at I, and we want to remove one object, and then just make sure that you subtract from the y and the length variables, the duration variable and the length variable. So for now we won't get any errors, and the bullets are actually now removed when they go out of the canvas. And to prove this concept, I can just change this to, let's say, 100, and they should be removed when they are 100 pixels from the end there, so you can see that it's working. So let's put it back to 0 for now, and let's start with the shooting of the aliens. Yeah, so let's do that. So to do that, I haven't figured out a real smart way to do it yet, but I have one method that works quite well, so we'll use that one. Just after here, where we update all of the bullets, just do another if statement, and we can say if math, the random, so this will be the frequency of how often the alien should shoot, so 0.03 is quite a good amount there, and the length of aliens, active aliens, is bigger than 0. That's just to get rid of a bug later on. And then we just say or take out a random alien from the alien list, so we do this math of round, math of random, times the aliens, the length, minus 1. Like that, and it will give us a random alien. And then just make sure that we get the first alien in the row of of aliens. Just loop through all the aliens again. So that's yeah, that's something we do a lot here. Just iterate through all the iterate through arrays. Anyways, just iterate through all the aliens. Save that to a variable a or something like that, and then we can say, actually we can't use a here. We will use b. B, for God's sake, yeah. Anyway, and then we can say if the two bullets, if the alien, if this collides with this, and we improve the height of this one, if they collide, we want to set the A to the B, oh yeah, instead. So for that work, we will need the AABB intersect method I have done in the Pong game tutorial. So let's make a function of this time, I guess, like that, and it will take the same arguments as last time. So as x position, a y position, a width and height of one axis aligned bounding box, and then the same for another one. So b.v and b.h, like that, and then we just return. So return ax is smaller than bx plus bw, and bx is smaller than ax plus aw, and ay is smaller than by plus bh, and by is smaller than ay plus ah, like that. So that's the basic intersection function here for you guys. And then we can say if AABB intersect, like that, and it will just take a.x, a.y, a.width, a.height, and then b.x, b.y, b.width, and b.height, like that. And then we just change the height here to, like, say 100, so that they will intersect. And then we just say a equals to b, and since we're looping from the, if we go back to the game here, since we are looping in this fashion, we go from the left like that, so then it will say if we choose this alien, then it will loop and it will collide with this alien, and then we'll loop again, and then it will collide with this alien, and so forth and so on. So that will eventually get to this alien, the front alien in that row. So, and then basically when we have that alien in the front row, we can just call the bullets push again, I guess, and a new bullet, like that. And then for the x position, we just use the a.x plus a.half of the width of the sprite, so a.width times 0.5. And then the y position is just a.y plus a.h, and velocity has say 4 pixels, the width 2, and the height 4 as well. And let's set the color to white for this one as well. So for now, if you have done this correctly, the alien should be starting shooting here. Yeah, that seemed to be the case here. And I think this shouldn't be inside of the for loop, of course it should be outside of it. That's why they shoot more than one bullet at a time here. Anyway, so there you can see that the shooting with the alien is working as it's supposed to do. So now when we have the AABB intersect function, we can actually check if the bullet from the player hits one of the aliens. So as you very simple, it will just say, we will just continue with this function here. So we can just say for this stuff again, and since we're using I above, let's use j here. So the iteration variable is j, and we just loop through all the aliens, and then we just take out aliens. So we can use a this time since we use a b for the bullets. Sorry, j of course, like that, and then we can say if AABB intersect if the bullet of x, bullet of y, bullet of width, bullet of height, if that intersect with alien of x, alien of y, alien of height, and alien of width. This should of course be the other way around, like that. So if they intersect, then we just want to remove from the aliens. So aliens alien.splice, j1, so remove 1, and then we just be len here, it should be len2. Then we just increment, subtract from the iteration variable, the length variable. Then we just remove the same thing for the bullets. As bullet I1 like that, and actually we can just call, yeah, let's do it like this. I'm not sure really if we should use break or continue here to continue with the bullet looping. Anyway, let's just loop through all the aliens anyways. So for now, if I hit one of the aliens, they should be removed. And why aren't they that? Yeah, so I figure out the error. It should of course be a len2 here as well, and then it should work fine. Yeah, so now it's working. I had the wrong length variable there. Yes. Anyway, so now we can see that we can shoot against the aliens and they are removed. So that's working. Anyway, so let's get the other way around, I guess. Actually, we can't implement that as the last thing we do here. So let's just do the cities now. So the cities, it's a bit more complicated than anything else we have done so far, but it's not as complicated as it shouldn't be possible to understand it. Anyway, so we will just create, after we have instantiated bullets here, let's just instantiate our cities to a new object, like that. Just make sure that you have declared the cities variable at the top. And it will actually have its own canvas element that will set to null at the start. Then a Y position that will set to the tank, the Y position, and then we just take -30 plus the city sprite dot h like that. So we got that done. So we have a canvas and a Y position and the height as well, and that will just be the city sprite of height like that. Then we'll actually have its own init function or method. I generate damage method, if I can spell it right. Anyway, yep. And that will take X and a Y position where to generate the damage. Then it will have a hits method. And that will just take X and Y position and checks if that particular pixel is solid, and that will be clear soon here, I guess. Anyway, so in the init method, we just create our canvas object. So we say it's .canvas equals document dot create element canvas like so, and then we set the width of the canvas to the width of the canvas like that, and then the height of the canvas we are set to the height like so. And then the context is really important, so let's just say, make sure this isn't really an important step, but I just like to type out all the variables we're using here. So I guess it's a bit, I used to do that in other more object-oriented static type of languages. Anyway, and that is just of course equals to this canvas get context, and that would be to the context. And then we just draw 4 cities to the canvas. So we say for var I equals 0, I is less than 4, I guess, I plus plus. And width drawn is a bit complicated. So the width of the canvas now are 504 pixels. So if you just subtract 60 from that and divide that by 4, you can see that we will get 111. And the width of the city sprite is 36 pixels. So we take 111, subtract 36, and we get 75, and then we just divide that by 2, and course need to have parentheses here. And that gives us 37.5. So we run that up to 38. And then we just add 30 to that value, since we want it to be offsetted by 30 pixels from the right. And we will get 68. So 68 is our key value here. So we can say this as context. The draw image, city sprite, image, and exposition. Sorry, and we will of course need all of this as well. So we have the city sprite x, city sprite y, city sprite dot width, and city sprite dot h, like that, and then the x position. Now it comes. So plus 68 plus 111 times I, and the y position is 0, and then the width and the height is of course the width and height of the city sprite, like that. So that's it. So that should generate the what do you say, the sprites we're going to use here. And then just to draw them, just go down here to the render function. Yes, and then we just can set screen.context.draw image, and cities canvas, and the x position is 0 this time, and cities y for the y position. And hopefully now we will get an error. Check what the error is. The type object is incompatible with the expected type parameter associated with the object. Well, that was a bit of a drawback. Of course, we haven't declared it yet. I'm so stupid sometimes. So just go up here of the init method again, and then after you have the cities here, just make sure you call cities.init, else it won't happen very much. Yeah, so now the cities are drawn here, and they are centered since we have done the math we did before here. So now we just have the sort of complicated bit of detecting if a bullet hits the cities, but we will actually do the generate damage function first. And this is have I done by some testing, I guess, so you can see if it's saved. No, it's not, but I basically just drew out. I can do it again for you guys. I just create a new stuff here. Let's just center it. Where are you? Where are you? There we go. Center, like that. And yeah, so I basically just took the brush tool, zoomed in a bit, and then I choose the basic shape I wanted to have here. So I think it's something like this. I'm not completely sure. But anyway, I just declare this sort of shape here. Then I choose an x and y coordinate. So I think this was the x and y coordinate. And then I just took the pixels values here, and then I just draw clear rectangles over all of the shapes here. So this should be x. If we say, since each of the pixels are 2 pixels wide, so if we say that is the x position, then this shape here will basically be what you say, plus 2x and minus 4y, and then to this position there, that will be plus 4x, I guess, and minus 2y. Anyway, so I've done this, and I'll just copy this over from the code I've done before here. So yeah, so here it is, and this should be down in the description. And basically we just take an x and y position and we floor it down, round it down, and then we draw all this stuff here. So we can say here underneath, let's just generate some damage, and let's take a position, so 68 plus let's say 6 pixels, I guess, and the y should be let's say 4 or something like that. So for now, go back here, you get an error, and I've got this in front of it. I really knew what the error is. Yeah, and so we actually can see it, let's add some more pixels to say 6 pixels, and let's say 8 pixels. And let's see, add even more pixels there. Anyway, yeah, so now you can see that basic generate shape function there for you. And so, sort of, all we need to do is just check, do this function, where we check if a certain object is solid. So for that one, we will use the get image data of the canvas rendering context object. So let's wait for it to load here. And it will take a x, y, and a width and a height of the data. You can check. And then we can just check against this image data object and check against some pixel value and see if that is solid or not. So that's why we have the own canvas for the cities there. Anyway, so let's get started with the hits function then. And yeah, so basically what it will do, it will take a y from the y, since that is the coordinate in the complete screen coordinate system, and then we subtract with the y value from to get a local coordinate inside of this canvas here, yes, you can say. And then we just take out the data, so we say this context.get image data of the x and y position and 1, 1 like that, I guess. So I will take out 1 pixel and check, and then we can say if the data and the third post, so that's the transparency layer. So we can say if that is not equals to 0, and actually we could use any value here since, yeah, but anyway. And if that's not equal to 0, then we generate damage to that position, so x and y position, and then we will return true, else we will return false like that. And then down here, when we are updating all of the bullets, we can just say something like, what do you say? If the y position, and we will actually use the centered position here of the bullets. It's a bit lazy, but anyway, I will do it like that. So bullet height times 0.5, I guess. And we can say if the cities of y is smaller than the bit of y plus half of the height, so the center of the y is smaller than the cities, and the center of the bullet is smaller than the cities the y plus cities the height. So if it's inside of, or if it's actually what do you say, possible to hit any solid pixel, then you can say if cities the hits b.x b.y plus h2, and we just want to splice from bullets and do all of this again, I guess. So we can just copy this, paste it like so, and then just tab it in, and we should be good to go. So now the game is actually in the finished state, but it will give us a real nasty error here, and that's a fault of the Chrome browser, I think, and that is this error: uncalled security error, failed to execute get image data on canvas rendering context 2D. The canvas has been tainted by cross-origin data. So this error is a real pain in the ass, and the only way I know to deal with it is to actually start a server with this file in it, or use another browser. So that's a bit stupid, I think. So just open up a terminal, and if you have Python installed, to check if you have that installed, you can just use Python B or something like that, and it should type out the version number for you down here or something like that. and the version isn't that important, but yeah, anyway. Now let's say quit, and like that. So just go to the folder where you have it, so Sublime Project for my case here, tutorials, Space Invader, like that, and then if you have Python installed, you can say Python simple HTTP server, like that, and that should open up a server for you at our post. So just go to localhost 8000, and now yeah, you can see that it works. So I don't really know what that error is about, but anyway, you can fix it by opening up our server or open the file up with a second browser. So that's the basic game there for you, and I will leave it to you guys to add what do you say, level system, score system, and stuff like that. So that's it from me, guys, in this week's tutorial, and I hope I see. I just think we should add one final mechanic to the game, and that's the mechanic where the aliens move faster when there are less of them. So let's just do that real quick. So just go down to the update function, and where we check if the bullet hits here. So if the bullets actually hit one of the aliens, then we want to do a switch statement of the alien length, actually. Actually, we can do it of the length 2 here, since that's pointing towards the length of the aliens. Anyway, so then we can just say if the case is 30, or like that, just break for now, and we have the case 10, case 5, I guess, and case 1. So, and this is how many ghosts there are. So let's say if they are here, it should be on the other end of it. Anyway, like that. And I have no clue why I did it like this, but anyway, let's get down to business. So yeah, anyway, so if there are 30 aliens left, then we want to set the level frame to some number here. And remember, level frame is the intensity of how fast they move here. So we can just set that equals to 40 for now. And if there are 10, let's set it to half that number, let's say 20. And if there are 5, set that to 5, 15 I guess, and 6 if there are just 1 left. So now, when I shoot the aliens, and they go below, and if they are below 30, you can see now they are moving a bit faster. Maybe not that it's here. Well, yeah, now you can see that they are moving even faster. And if I shoot some, so they only are 15 of them left. Yeah, or 10 of them left. Now they are moving even faster. And if I hit, so they only 1 left, you can see that it's moving real fast and that it's shooting like a maniac. But anyway, I think that's the final game there for you guys, and I will leave the rest to you. And thank you for watching, and I hope I see you in the next video. And I'm thinking of developing an asteroid game. Yeah. So yeah, thank you for watching. Bye.